The exponential distribution is one of the many distributions that can be used to calculate the probability of events occurring. The cumulative distribution function for the exponential distribution is the probability of x less than or equal to x equals 1 minus e to the negative lambda x. The expected value of the exponential distribution equals 1 over lambda. The variance of the exponential distribution equals 1 over lambda squared. Let's look at an example. The wait time at a taco truck is an exponential random variable with parameter lambda equals 1 over 4. Determine the expected value and variance. What are the probabilities of waiting in line less than 1 minute, more than 3 minutes, and between 1 and 3 minutes? The first part of the question asks us to calculate the expected value and the variance of the probability function. We know lambda is equal to 1 over 4. The expected value of an exponential distribution equals 1 over lambda, which equals 1 over 1 over 4, which equals 4. The variance of an exponential distribution equals 1 over lambda squared, which equals 1 over 4 squared, which equals 16. For part B, let's start with the probability of waiting less than 1 minute. We want to compute the probability of x being less than or equal to 1 with the parameter lambda equal to 1 over 4. The cumulative density function of the exponential distribution is the probability of x less than or equal to x equals 1 minus e to the negative lambda x. Substitute 1 for x and 1 over 4 for lambda to get the probability equals 1 minus e to the negative 1 times 1 over 4. Simplify the exponent to get the probability equals 1 minus e to the negative 0.25. Evaluate to find that the probability rounded to 4 decimal places equals 0.2212. There is a 22.12% chance of waiting in line less than 1 minute. Now compute the chance of waiting more than 3 minutes with the same parameter of 1 over 4. The probability of the complement of an event is equal to 1 minus the probability of the event. So, the probability that x is greater than 3 equals 1 minus the probability that x is less than or equal to 3. This equals 1 minus the difference of 1 and e to the negative lambda x. This simplifies to e to the negative lambda x. Substitute the values for lambda and x to get e to the negative 1 over 4 times 3. Simplify the exponent to get the probability equals e to the negative 0.75. Evaluate to find that the probability rounded to 4 decimal places equals 0.4724. There is a 47.24% chance of waiting in line more than 3 minutes. Finally, find the chance of waiting between 1 minute and 3 minutes. Calculate the probability that 1 is less than x is less than 3 with the parameter lambda equals 1 over 4. Notice that this is the complement of the probability of waiting less than 1 minute or more than 3 minutes. So, the probability that 1 is less than x is less than 3 equals 1 minus the sum of the probability that x is less than or equal to 1 and the probability that x is greater than or equal to 3. Substitute the values calculated previously and the equation becomes the probability equals 1 minus the sum of 0.2212 and 0.4724. Add what is inside the brackets to get the probability equals 1 minus 0.6936. Finally, subtract to get 0.3064. There is a 30.64% chance of waiting between 1 and 3 minutes.